Thank you.
Welcome, Kat.
Thank you. This is going to be the only stream that we have, so if you just click the full stream button and then tap on ours, that'd be great. All right. We have a presentation here for you guys. We are FTC, Can Hack Comes Back. This is our 6th year, and we are run through our local Sherburne County 4-H group. In that STEM club, we have a couple of our team members as officers. I am the president, Matt is the treasurer, and Evie is the vice president. And Matt is here to talk about our aesthetically pleasing robot.
So this year, for our robot, we went with a 3D printed drivetrain with mechanism wheels that allows our robot to stay lightweight and maneuver around the field quickly. The 3D printing also helps us get more complex shapes to improve the aesthetics of our robot. On the front of our robot, we have this intake. These wheels have a surface speed of 15 feet per second, so it pulls the rings in very quickly. And then a transfer system with TPU sweeper flappers bring the ring up to the launcher, where both the wheel and this rail on the other side have a groove, so it self-aligns the ring up and down to minimize errors there. This wheel weighs 15.5 ounces to keep up the momentum as we launch 3 rings in under 1.5 seconds. On the end of our launcher, we have this innovative aiming device that we can push in or out to direct where the ring goes so we can score the high goal or the power shot without actually turning our robot. On the back of our robot, we have this wobble goal arm that allows us to quickly grab wobble goals and deliver them outside the field.
Hi, I'm Grayson. Our team uses CAD for rapid prototyping to design our parts as quickly as possible. We have many iterations, including our side wheel drivetrain, which didn't pick up rings very efficiently, which we changed to the top wheel drivetrain, the intake, which works much better. We also have changed our launcher wheels. We have changed their profile and weight to get the best accuracy for our launcher. And last of all, I want to talk about our wobble goal arms. We have a lot of different iterations of these, and we are able to make them all in a relatively short time frame thanks to CAD software.
Hi, I'm Megan. We have done 20 outreach events, and I will share 3 connected examples, although there are many more in our notebook. With the challenges of COVID, we met with Chad Elliott, an environmental health and safety manager at Eaton. He shared how Eaton is addressing COVID safety and precautions we should take for safety at our site. We then met with CJ with Chef Engineering. He provided feedback on how to improve our Wobble Gold gripper. We met with Nick, who's a St. Thomas Mechanical Engineering student and an alumni of Height Differential. He reviewed and provided feedback on our CAD drawings for our 3D printed drivetrain.
Hi, my name is Daniel. I joined this year. Last year, 4 seniors graduated. I have been learning from experienced players about programming, soldering, and other interesting things. Joe is also a new member to this team.
This year, despite COVID, our team has been able to do much outreach with other teams. At kickoff this year, we did 2 presentation videos on mechanism wheels and great presentations. We also did some fun teaser videos for them as well. We also held a robot in 2 weeks competition where we and 5 other teams were able to compete and show ourselves. Can be contacted at any time through our many social media platforms such as YouTube, Discord, and Instagram.
For our robot, we use a combination of additive and subtractive manufacturing. And for additive, which is 3D printing, we have 93 parts. And for subtractive, which is CNC, we have 58 parts. And all these parts we design ourselves in-house are CNC routers to my left. And this allows us to have a much wider freedom in what we test, and just allows us to redesign parts quickly.
And now, since we've hit that 5-minute mark, we're going to open up the floor to any questions you guys might have.
Sorry, I was muted. Thank you. That was a great presentation. Very well thought out and very well structured. Can you talk a little bit about how you decide when you should use 3D printed parts and when you should use other parts, whether it's CNC or other things that you're using?
Yep. So we go with 3D printed parts. I'm gonna switch to the when we want to either combine multiple parts together with more like complex shapes that we're unable to achieve with other processes, or when we want to keep something lightweight, or just stuff like that. For like larger parts that don't have much depth to them, we can do those with the CNC very quickly. Instead of printing a flat sheet of plastic, we might as well just use thin sheet metal that we can do shape optimization to save weight. Also, there's a strength factor there. 3D printing is very strong, but it's still plastic. So if we have a part that we need small and strong, then we'll go to metal. Otherwise, we tried to make as much use of 3D printing as possible because it looks nicer and it keeps our robot lightweight.
And you can find more of this in the engineering portfolio as well as the notebook, which Evie can talk to you more about.
Yeah, so our engineering notebook, we have a style guide for it, and in the style guide, it lists stuff about like what colors and text we should use, borders, and even information about the robot, and what colors we should use for that each year. We use the style guide across the whole notebook, so it keeps it looking professional and sleek. And our notebook has been reviewed by one of our mentors, Sarah, and all of our team members contribute to the notebook.
Okay. So you had great information about your STEM outreach. Have you been able to do in person, or has that been mostly through using technology like Zoom? And what technology are you using for that communication?
So for the Robot in 2 Weeks scrimmage, which we hosted, which was previously hosted by an FRC team, we actually used OBS to put together the video, and then we streamed it to Twitch so that teams could watch, while we had, I think, Discord open so that we could get the video from all of the 5 other participating teams. We have had some design reviews and video reviews that were in person with a couple of our mentors. So that was also fun.
So let's talk about that Robot in 2 weeks for just a second. How many teams did you have involved?
So we had 4 other teams involved in that, which Evie can tell you more about.
Yeah, so we had the 4 different teams, and like Grayson said, we had them all in on Skype, and then we streamed it to Twitch through OBS. And it was we sent out a thing through our different social media sites asking who wanted to be in it. And as the day went, we didn't have only a couple very, very minor technical difficulties through all the teams, which was really great.
Did you only have Minnesota teams, or were you able to reach out? Since you were online anyway, were you able to get some teams from other places, like teams that maybe Cat and Hat has competed against at Worlds or things like that?
So we did open it up to anybody on Twitter and stuff, like all of those FTC teams, but we were only able to get Minnesota teams.
Okay. So tell me a little bit more. What's the most unique thing about your robot that, especially since you've seen some other robots at Robot at 2 weeks, what's unique that maybe is new to you that you've never done before or that you've never seen on another robot? I know you guys do a lot of online research, so.
Yeah. So a really unique thing is the drivetrain. It's 3D printed. Allows us to combine a whole bunch of parts together, makes assembly easier, keeps our robot lightweight, and it looks really nice. Another unique thing is our aiming device on the front here, so that we don't have to turn our robot between the high goal and the power shot. And that works really well with just this servo sliding this part in or out to push this either direction. Another unique thing is our launch wheel is actually, we use a PID to regulate the RPMs of that motor so that we know we're always spinning at the same speed to launch the wheel. Battery level doesn't affect us, and we can get back up to our top speed or our target speed without overshooting.
Mhm. And as well as our robot, we have some programming which is also very cool and unique as well, which Jacob can tell you more about.
Yep. So basically, we use odometry to be able to map out where the robot is on the field. We're also able to push the robot a little bit, and it will also find where it's supposed to go to its point. We also use OpenCV as our vision, so that we're able to find the rings on the how many rings are on the field, so that we're able to drop off the wobble goal in its designated zone. We also are experimenting with pure pursuit, so that we have more gradual curves instead of just sharp, jagged turns. And also with our odometry, we are trying to get integrated where in teleop you have you're able to press a button and the robot will turn to the right angle to be able to shoot the rings instead of having to go to the same position each time to shoot those rings.
Okay, you talked a little bit about your automatic positioning. What are you seeing for scores, guys and gals? What are you seeing, team, for scores consistently?
So we've been getting a consistent average of 200 through our scores with a top score of 262.
Our official matches, one of them was quite low because we had a stall out problem. We got that fixed and got back up to that high score.
I love your directional shooter. How early in the design process did you realize that you wanted some way to control that?
Pretty early. Like that was in, I think, the second iteration of that launcher rail, that outer rail.
Mhm.
Because as soon as kickoff came up, we knew that we would want to be able to shoot in the high goal and the power shot. And instead of taking the time to turn the robot, we figured we can just slide that over and that would help a lot. So that was one of our early decisions.
And we keep track of all the iterations in our notebooks so we can go back and look at what we did and didn't like about each design.
Very cool. There's many, many unique things about you guys, but one thing I noticed is when you're shooting your rings, you're all the way to the right side, right up against the wall. That's obviously a cool strategy because I'm guessing that's because then you have, there's no guessing on left or right. You took that element out of the equation, right?
Yep.
How early in your process did you realize, hey, let's do that so we have consistency?
That was also early on because we knew we wouldn't have the auto positioning done in time. That for our first tournament, we decided we're going there so we can just square on the wall, make sure we're lined up, just to reduce any accidental missing the rings.
Very cool.
Yeah.
So can we talk just a little bit about your team goals and team member goals too? So where do you see how do you see how COVID has really impacted where your team is headed? Do you see how it will shape next year, or what you would keep from this experience for next year, even if we're able to have in person?
So I think this year we weren't even though there was still COVID and stuff, we still had new team members to keep the team going and stuff. I think one of the things that we would keep is some of these online outreach events that we could do so that even though somebody is like in Wisconsin or Maine or something, they can still talk to us and stuff.
As for team goals, we kind of looked at what everyone's goals were at the beginning of the year and then worked with it from there and still tried our best to fulfill everybody like what they wanted to do on the team, different things they wanted to try out and stuff like that, and tried to accomplish those as best we could, and we did a good job of that.
Okay, great. So, do we have seniors on the team this year?
No, we do not have any seniors on the team. We will
Juniors. Do we have juniors? Okay, who's our juniors this year?
Raise your hand.
Okay, so you guys are getting ready to make some big choices here soon, aren't you? Did any of you apply for Dean's List? How did it go? I'm not seeing anybody that applied.
I don't think any of us have applied yet, unfortunately.
Okay. Okay. I'd encourage you to consider it, especially if you're considering anything that ties to robotics. And remember, tying to robotics does not include just building robots. It's all of that marketing, development, planning, all of those things. So talk with your coach about those opportunities. Also coming up is the scholarship opportunities. And those are juniors. So remember that, sophomore and juniors. This is your year for that. So younger members, do we have 7th graders? 8th? Who's our youngest? Yeah. Who's our youngest?
I believe, yeah.
So did you come to FTC? Did you do FLL before, or is this your first jump into robotics?
I had done FLL for 4 years before on a different team, and then I heard about this team, and they sounded really fun, so I came here this spring, fall actually, and I really liked it, and I decided to join.
So what's the biggest difference? I apologize. I know this isn't really what the judging is, but I really love to hear what's the biggest difference, the biggest advantage, disadvantage. What do you miss most about FLL? What do you see that really has grown? Not to put you on the spot, but yeah, I do mean to put you on the spot. Go for it.
So one thing that I really like about this is when I was in FLL, it focused solely on using Legos, and this opens up a whole lot more opportunities because you don't have prefabricated parts as much, and you can custom make anything, any shape, any type that you want. And I really like that it has that amount of versatility. It's really nice, and I really want to learn more about the different ways that you can do that.
As well as for programming, we can actually use stuff like odometry, and we can also powder code metal parts as well, which is really fun.
Okay, great.
All right, I got to be the timekeeper here. I think it's time for us judges to break out.
All right. Thank you.
Thank you.
Yeah, thank you.
We'll be back. We'll be back.
We'll be back. Thanks, everyone.
Yep.
Thank you.
Hi guys. Very nice robot. Did it fit in the 18-inch box the first time, or did stuff have to get trimmed?
It did fit in 18 inches. We originally designed it to fit in a 14-inch cube.
Oh wow.
We had to, after we built it the first time, we had to expand it a little bit to make more space for other parts. But yeah, it was never over 18 inches. I think right now the biggest measurement is 17 and 3/8. No, 17 and a half.
Okay.
So we have extra space.
Cool. So what was your biggest software change for this year? And what software feature did you add along those lines?
Well, this year, we added OpenCV for our vision, for it to see the rings. And yeah, that's probably the biggest change that we transferred over to this year.
Okay. Cool. And I noticed in your control award video, you have one portion there where a team member reaches in and pushes your robot and it goes back on its merry way. That is very nice. You should be very proud of that. Did you have that last year or is that a new feature for this year?
We did have that integrated last year as well.
Okay. Still, it's very nice. Mike, did you have any questions?
This is the first week I was able to figure out how to watch the match videos. I realized that at the end of the previous tournament that I judged or helped with. So it was definitely impressive to watch the entire match run and all the scoring that you guys did. And forgive me if I missed this. As far as like you mentioned earlier, as far as early in the season, you decided you wanted to be able to both shoot the high goal and the power shots. Is that right?
Yes.
Yeah.
And the, I guess there was something that I thought about from a strategy standpoint that I thought you might have considered with parking where you did on the sidewall. And I know you talked about earlier with the judges, it was more as far as your auto positioning. Is that right?
Yeah.
We're going to have that ready. Are there any other advantages that you guys have appreciated if this was an in-person year with where you're set up to do those shots?
I mean, I think between in person and here, we get to have everything more accurate here just because we're the ones setting it up. So that's more of an advantage for us, so that we're able to place a wobble goal right on where it's supposed to be able to pick it up. We're also able to be able to go to our right position to shoot it, and there's no really difference in where we go.
As well as we wouldn't be running into any other robots as well.
I also think it's nice that we don't have to compete with other robots to get the rings. We have them all for ourselves.
Another thing with lining up next to the wall there that helps with is we can kind of sight along the robot into the goal with still standing in the driver area. So we haven't really had to sight along the robot like that much because it's always lined up when it's flat against the wall. But if we did need to, we could still see it without stepping out of the driver area.
Very nice. What kind of sensors do you folks use on your robot? Go through your array of different ones.
Some of the sensors that we use on the robot are the encoders for our odometry, and we also put an encoder on the wheel right here so that we're able to see our how fast our wheel is spinning. And we also have an IMU that we use to calibrate our odometry so then our odometry is accurate.
We also experimented with some distance sensors, but we found that our odometry was accurate enough that we didn't need to complicate things more. We decided to keep it simple because it was working well.
Cool. So where do you mostly use the machined aluminum? I know you said where you have a flat plate, but could you show us a picture of where some of those machined aluminum parts would be? That's not very often we see them on FTC robots.
Yeah. So one of them is our crossbar right in the front here.
Okay.
This we wanted it very thin so it didn't take up much space. So it just connects the two drivetrain sides together. There's another one in the back. Also these sides of our intake here are CNC'd out of aluminum. And there you can see some of the shape optimization we did to save weight.
Mm-hmm.
The other biggest metal part we have is these white parts you can see here. And that's really to hold the two motors that we can tension in and out there.
Oh, okay. Very nice. So you got slots cut in there for motor tensioning there.
Yeah.
And then those brackets are metal too then? The like L brackets there? Yeah.
Yep, those are metal. Those hold the outer end of the axle for the wheels.
Okay. And those are all custom designed by you guys?
Yep. So custom cut, and then we bent them on a brake that we have, and then powder coated them.
Hmm. Cool. Oh, what was it? So on your more back on your software there, did you say, I believe it was in your notebook perhaps, or in your portfolio, that you indicate the controls to the driver, how much time is left by flashing your lights different colors? Is that correct?
Yes, we do have LEDs on the robot, where basically, yeah, we just have these different red. We have red LEDs right now, and we can also change them to different colors depending on how much time is left.
Oh, very nice.
We also change colors in autonomous based on how many rings the camera sees.
Oh, cool. So which of the robot build rules gave you the most trouble this year? Or not trouble, which was hardest to accommodate? Would you say the size, the number of motors? You know, could you have used 9 if you have 8, kind of thing?
We could have used 9. We could have put an extra motor on the launcher to keep that wheel spinning faster at the same speed.
Okay.
But there's other places that we can take a motor away from to get a motor if we needed that. I think one of the biggest thing was the launch distance, keeping it under 16 feet. That's less of a build side of the robot, but that was a lot because, of course, the higher power you have, the more accurate it's going to be. But we had to keep it under that 16 feet. So that it was kind of a struggle for a little while to get it accurate and under 16 feet, but we made it.
Okay, I've heard a lot of that one. I give you a tip of the cap. You're one of the few teams that has your team markers on today. That's good. A lot of them seem to be forgetting that, and some of them even forgetting numbers. So from a referee side, that's very nice to see. So who does your refereeing, and how do they keep up on the rules?
So we have, for some of the matches that we did have a team member do it, as well as one of the coaches for most of the matches that we did it.
Okay.
We would make sure to look through all the rules and stuff right before we did the matches.
Oh, cool. Wow, it's just such a good. Could you go back to your view where it's just the robot, please? So on your grabber there, your Wobble Go grabber, do you have any sensors in there, or is that just manually you align and then you just?
We use the encoder on this motor to know what position to put the arm to. And this grabber is operated by a single servo.
Okay.
So that always just goes to the exact position, open and closed.
Okay, so you don't have any sensors in the grabber mechanism to help with the alignment or anything. You rely on it self-centering.
Yep.
Okay.
Yep. This opens up wide enough that we actually have a 5-inch range here that we can grab the Wobble Go.
Okay. Cool. Are your drive halves pretty much mirror images of each other? Or are they both unique, or?
Yep, they're just mirrors. The only difference actually is that we included part numbers, and I don't know if you can see it on the camera, but we included part numbers on all of our printed parts.
Oh, wow.
So that's really the only difference between the two sides is one is 47, the other is 46. Those numbers are preceded by cat-thing-D for drivetrain. Other than that, yeah, it's just mirror image.
Okay. Are your wheels, your idle wheels for your reckoning, are those spring loaded, or are those just always forced into the rubber, into the floor?
So the odometry wheels have a elastic piece that's attached to them and then attached to their mounting bracket so that they'll push down with more force to make sure they're always spinning along the ground.
Okay, very nice. Well, it looks like the judges are back, guys. Thanks for sharing your time with us on the robot. Very nice looking robot. Very, very good job, guys. Good luck.
Thank you.
So nice job, guys. I know it's hard when you are a experienced team. Sometimes we place the bar a little high. So as you've had a chance to talk with the referees, is there anything you told them that we missed as judges that you'd like to share again, or anything that maybe didn't get discussed, or maybe has been discussed and you want to say it one more time so it really seats into our brains as the most important thing we should know? Maybe each of you take a moment to just share a thought with us.
So what we shared with the refs that we didn't have a chance to share with you guys was the sensors that we use, which Jacob can tell you more about.
Yeah, so basically, we just have encoders on the odometry wheels down here. We also have an encoder on the arm. We also have an encoder on the launch wheel so that we're able to get the same RPM each time, no matter what percent the battery's at. We also have the IMU on the robot so that we're able to calibrate the odometry encoders.
Are you using any color range sensors?
No, we are not using any of those at this moment. So,
And how do you, I'm sorry, I missed it. How do you sense how many rings are on the field in Auton?
So basically, we use a camera with OpenCV.
Okay.
So yeah,
So I'm gonna include that in your sensors. That's all you have to tell me. Thank you. Camera.
Another unique thing that we told the refs was all of our 3D printed parts are labeled with a part number. And that makes it really easy if we ever need to replace a part or modify a part. We can just really quickly, easily see which part that is.
Hey, could you show me your odometry wheel one more time on the bottom? How many wheels, how many Omni wheels is that, 2?
So this is one. It's kind of like 2 wheels together, but it's
Okay,
one.
thank you. On the because the video looked like it was almost 4. I was just curious why 4. But okay, I see now. It's 2. Okay, thank you.
Yep.
Hey, I have a question. It's so cool that you did the 3D printing for your drivetrain. Were there any disadvantages to that?
Not that we ran into with this one. It made it really easy to assemble parts because the drivetrain was really just one giant piece,
right?
Or pieces. But a disadvantage that could be possible, if it were to break, we would have to replace the whole thing instead of just one part.
Yep.
But we have had problems with that.
No, it looks very, very cool, very impressive.
So what materials are you using for your printing, for your 3D printing? It doesn't look like all PLA.
Our robot, we have a few different materials. Most of the parts we printed are PLA, the solid ones.
Mm-hmm.
Though we have a few in TPU, like our launch wheel aimer is TPU so that it's flexible, along with the pieces inside our transfer. And another TPU piece is this belt. that has fingers on it. So that it can just go in the robot and it'll move the rings really simply. And then our drivetrain was 3D printed by Stratasys, and they used ASA, a material called ASA, I'm pretty sure, which is stronger than PLA. So that's
impact resistant.
yeah.
So did Stratasys recommend the use of the stronger material, or was that something that you requested?
They actually recommended that material. We weren't very familiar with 3D printed drivetrains, so
Okay.
we just went with whatever they thought would work for that purpose. And it's worked really well. We haven't had any problems. Another material, we actually use a different 3D printing process. We have these Stratasys logos on the back. These were actually printed on a PolyJet printer, so we were able to get the multiple colors in the one piece.
Okay. Can we talk a little bit about your interaction with other teams? You talked about the Robot in 2 Weeks tournament. I know in the past there's been a lot of collaboration. You guys have reached out to other teams. Are you mentoring another team? What are you doing this year for your outreach?
So we did in that hub that we were talking about that we run and stuff. There are 2 other FLL teams which we do mentor. Matt mentors one of them as well.
Yeah, so actually in the past couple days, I've spent about 10 to 12 hours helping them get ready for their tournament. They are actually competing today as well.
Okay.
Just helping them through like practice judging.
Last fall, we also joined a cohort, which is a group of teams, and we would share and discuss ideas.
You'll have to forgive me. You might have already said this, but could you speak a little bit about engineers or folks in the engineering community that you interacted with this season?
Could you repeat that question again, please?
Yeah, just did you reach out to any engineers this year?
Yes, we reached out to CJ as well as Mike Elke as well.
Yeah, CJ is a mechanical engineer. Where's he working right now?
Chef engineer.
He's one who we met at one of our fundraising events.
Mike
What did
Elke-
you learn?
Oh, sorry.
So
Go ahead.
I was just going to say that Mike Elke is an aerospace engineer.
And CJ helped us with a design review of our robot after we got like a good start on our robot, had it working and driving. He gave us some advice of like different things working, especially the Wobble gold gripper. He gave us a lot of advice on that we were able to rapidly iterate and improve it to what we have today.
So I'm curious about your sustainability, and you had your SWOT analysis. Can you talk a little bit about that?
Yeah. So in our business plan for that, we have that SWOT analysis, and we came up with that at the beginning of the year so that we know what we need to do as well as what we're good in.
And so what takeaways did you have? Because you have a lot of what you discovered, but how did you help fix some of these weaknesses?
Yeah. So one of the weaknesses that we found this year was that 4 of our seniors aged out. So there were lots of areas where we didn't have the same level of expertise, like programming and notebook. And we just, they mentored us really quickly, and we took that, and we also trained our new team members as well into that very rapidly as well.
Awesome. And then I was curious about your guys' design process. Did you want to walk me through that the flow for your engineering design process?
So our engineering design process, we find the problem. This one's a little lengthy, but yeah, we find the problem and we think of solutions, and then we can change. We specify our constraints on there, and then we can start doing the CAD process and designing it. Sometimes we write it out on paper and then design it on the computer. So then we can print or cut it out really quickly, test it, and then improve it as much as we want until it's at the level we desire. And then we can review it and discuss with the team. So
Okay.
that's
And what part of your robot, what kind of benefited from that design process the most?
So I believe that the tail, the Wobble Go Gripper, was the one that profited the most from that one.
Yep. So you can see we have a lot of iterations of that tail that we were able to rapidly iterate through because of that process. We have even more iterations in CAD, which gives us that advantage where we can actually test things in CAD using finite element analysis and all that stuff, and also make sure everything fits together. So we can rapidly iterate there before even manufacturing the part.
Great.
So, real quick, is this your guys' first tournament of the year?
Yes, it is.
Okay, I have to compliment you on your presentation skills on this. That's very nice. I really appreciate the microphone, but I also like that you guys apparently have a screen back here, behind me, where I'm looking at you from, and it's really helping with that presentation. You're really looking nice and professional. I also like how you've obviously set up your split screen, knowing where that screen is going to be for us, so that you are visible in our screen. So how much time did you guys have to spend on figuring that out? Did somebody take the lead on that? A couple people spend some time figuring out this is where we stand, and then coach the rest of the others?
So how we started with that is both me and Jacob had previous experience in OBS from like streaming sports games and stuff. And then we decided we wanted to do something, kind of special for the presentation. And so a couple of us got together and brainstormed it, and kind of came up. We wanted like the split screen and the robot camera and the nice thing there at the bottom. And so then we kind of worked together with some other team members, but specifically like Grayson's graphic design skills, and worked together on that. And I think he's going to want to tell you more about that.
Yeah, so we wrote out our ideas for each scene, and everybody had notes for what they were going to say in the presentation. So I opened up Inkscape and made some graphics for each scene. And in OBS, we had to put together each scene as well, like cropping cameras and placing them. Overall, I think that took, I don't know, I'd say 5 hours of work for moving everything and setting it up, maybe a little bit more.
And a few more hours of practice.
Yeah.
Okay. One thing I'd recommend that a lot of teams really struggle with, and you guys really excel at it. So I just want to put it out there as an idea for you to consider. The presentation, a lot of times we forget that if our robot's awesome or whatever it is we designed, if we can't explain it to somebody, it doesn't get past us. And so you guys are really doing a great job of explaining how you got where you are and what you're doing. And some of those younger teams that are struggling, or startups, they really struggle with what the purpose of the judging is. And so as you're doing your outreach, I mean, you've got some great outreach going with your hub and everything else. I'd encourage you to maybe think about helping some of these teams understand the process of judging. It's the one part of these tournaments we can't see. And so as a as you think about some things to improve on, I'm really struggling with finding for things for you guys to improve on. So, some things to improve on, or some next steps to think about, is how you can help some teams that they don't get to see this part, help them understand what the purpose of that presentation is, because yours was incredibly thought out, was very well presented, and it really makes it possible for us to understand what you did in a very short period of time. And we see teams that they have great design skills, they have all of that, but they don't tell us, and we can't help them. We can't judge them appropriately. Versus you guys have really laid out your design process, and you've laid out your whys and whats. And I think that's a great place for you to take and expand on your opportunities that you're reaching out. So congratulations, guys. You did a beautiful job today. I love to hear that you guys actually laid out that presentation process and that it's you. I loved hearing about your robot today. Very involved and very good job. We have just a few seconds left, so we have to go and argue to the other judges about why which team should be considered for which award. If you could only get one award other than Inspire, if one award that you want us to really, this is the one that we really want, which one is it other than Inspire? Because everybody wants Inspire.
I think it would be Think.
Yeah, we actually had, so the person who worked the most on the notebook was a senior last year, Sarah, and so she aged out. And so we had a little bit of a process trying to like work on the notebook and trying to get everything sorted out. And I think we did a really good job by the end of it. Our style guide makes it all look really sleek and professional. And, you know, everybody on the whole team contributed to it, and put stuff into the programming notes, and we really pulled together at the end to get it all done.
So as Teresa mentioned here, we are wrapping up now. Luckily for us, we have a gap following us. We had maybe an extra minute or two to talk to you guys. You guys are obviously a high flyer team, right? And everybody knows that. There's no questions. But then what separates the highest flyers from the others is heart, right? And so before we go, I'd love to hear from as many of you as we can. What is something you are so proud of? Or what is something that is so cool? Or maybe it's something that hasn't been talked about, or maybe it has, but you want us to remember that as we go off and talk about you. But this is your chance to show me heart, because you've proved your robot, you've proved your portfolio, but show me your heart.
Yeah, so at the kickoff, I really enjoyed doing the two presentations we did. The first one we did was about how to have a great presentation, and the second one we did was about Mechanism Wheels. And I just really enjoyed teaching other teams about and sharing all our knowledge with them, and that was just really enjoyable for me.
Thank you.
And I really liked the way that we got this OBS set up for the Discord. It looks really good.
My favorite thing was just, this team, because, COVID was hard for everybody. And so being able to come here and just, mess around a bit and work on robotics and just be together with the rest of the team that was definitely my favorite part.
Thank you.
I just love a lot about it, like getting to be in such close proximity to technologies like CNC and 3D printing and designing a robot and doing graphic design. I also really enjoy. So there's so many technical things that I just love.
I also like that how much creativity is allowed in this sort of things, like a combination of fusion and how CNC routing and 3D printing just allows us to be as creative as possible with how we solve the issues that on the field.
I really like just coming here every week is really nice, especially with COVID. There's not a lot of social events going on, and it's really nice to come and to be with people who are like me with their creativity and their ideas and stuff, and to be able to kind of flourish under that is really nice.
Excellent.
To both what Evie said and what Joe said, just that we were still able to function as a team despite everything going on this year. That's really important to our team.
Very good. Did we get to hear from everybody?
I like how Every time I come here, I learn something new.
Yeah, something I really enjoyed, kind of like what Daniel said. I'd like to learn something new every day. So like I didn't know much about programming coming into this year. I did a little bit last year, but this year I got to really dive deep into it. I did some of the autonomous and got that started working on that, and that was really my first real programming experience. So yeah, I really enjoyed that.
Excellent. Is that everybody?
Yes.
All right. Well, second, what Teresa said before, you guys are obviously you're killing it. You're doing so well, and we can see the joy that you guys get from doing this. I'm betting that Dan is somewhere in the room. So Dan, if you can hear us, and other coaches, my hat is off to you. Well done as always. Well done. Well done. Well done.
Thank you.
Thank you.
Thank you. Good luck today, guys.
Thank you.
Thank you.